different techniques, and this is again, some of it is biologically inspired. We try to take inspiration from human brain and see what kind of innovations are driving LLMs towards being more efficient, both on the data and compute side. So sparsity is a phenomenon that we humans exhibit. At any point in time, it is said to be the case that for different kinds of tasks, certain parts of our brain gets activated, and that helps to really solve the tasks. So what we call as lighting up the brain, and out of the trillion plus neurons that we have in our brains, not all of them are active at all the time, depending on the kind of tasks. Like if it's a memory retrieval, there could be a certain set of neurons which will be more active working on that particular task. Whereas if it's long-term reasoning, if that's emotion, again, there are like different aspects or different parts of the brain being activated to be able to answer that particular tasks, right? So similarly, I think on the LLM side, we can benefit from sparsity, and there are already techniques like mixture of experts, which is using this phenomenon inspired from brain, where in order to train a giant neural network, again, we can borrow the same analogy where we don't need to have all layers of the neural network active all the time. Instead, if we can somehow activate certain parts of this neural network to be able to answer a question, then that can be more efficient. So mixture of experts is one of the architectures that is popular. It's gaining traction, and GPT-4 is believed to be trained using a sparse mixture of experts model. And based on rumors, I think what we've been hearing is, so this is really GPT-4 has 16 expert networks, and each network itself is a 111 billion parameter model. Right. So overall, this gets to about 1.76 trillion parameters if we were to combine all of the 16 experts. But the practical implication of this is, at any point, only 2 experts out of the 16 are going to be active. So which means at any point, 2 into 111 billion parameters are only going to be active, which is a 220 billion parameter model. Effectively, we get access to this huge 1.76 trillion parameter model. But from efficiency standpoint, at any point, we are only going to be activating about 220 billion neurons at any point in time for a given task or question at hand. So this is sparse mixture of experts. Of course, there are a few open source models like Mistral, which released its mixture of experts model called Mixtral 8x7b, which is 8 experts, each of 7 billion parameter size. And this basically outcompeted some of the more popular models like GPT 3.5 on varied benchmarks. And I think there are more bigger models coming with this mixture of experts architecture as the main innovation. So this is one on the training side. Again, we have other techniques like LoRa, which is again cashing on the concept of sparsity. And this is again based on the same intuition. If you have a giant neural network with 1 billion plus parameters, then, or 100 billion plus parameters, then this is going to be a huge task if you were to adapt this model for different tasks. So the intuition here is, again, can we break this down into a low rank adaptation, which is a low rank matrix multiplication. So we don't disturb the full pre-trained model. Rather, we train what is called as low rank adapters that would basically learn, these are small neural networks that learn custom representations for the given task, and then they would get merged with the pre-trained weights or pre-trained models to be able to generate a fine-tuned or adapted version of the model. So this is called LoRa fine-tuning, low-rank adaptation, and this generally comes into the category of parameter-efficient fine-tuning techniques. So again, all of these are leveraging the fact that you could basically use sparsity to your advantage to make sure you're not basically boiling the ocean. Rather, you're looking at targeted updates to the model in order to benefit for the given task. So LoRa has multiple advantages beyond just efficiency that we spoke about. For instance, this could avoid overfitting, catastrophic forgetting, where we know that catastrophic forgetting is a problem in neural networks, and LLMs are no exceptions. And having these techniques like LoRa, we can really reduce the chance of catastrophic forgetting, because you're only going to update a small portion of this large neural network. So the chance of the fine-tuning, erasing the knowledge gained from the pre-training is becoming minimal. And the other way to put this is, this helps in better generalization of the model and not lead to any overfitting problems to this particular task. So that's on the sparsity. So this is a very clean, clever technique which is biologically inspired, and we've been able to use it in LLM training inference.